Hey everyone, this is an example from section 3.1. It's going to be basically taking an equation that's in standard form for a quadratic and putting it into vertex form. And we got to use completing the square to do that. So this is an example basically of how to complete the square. So if you remember from completing the square, if we start with x squared plus 6x minus 14, what we really want to do is we want to take the middle term and we want to divide it by 2 and then square it. So I'm going to take the middle term and I'm going to say, all right, this is really, we want to say b over 2. We call this term a, b, and c. We want to take b over 2. We want to square it, which would be 6 over 2 squared, which would be 3 squared, which is 9. So 9 is this number that I need to use for this function. So what I'm going to do is I'm going to write this as, I'm going to add 9 basically to this side, and I'm going to add 9 to this side. So it's going to be f of x plus 9 equals x squared plus 6x plus 9 minus 14. So if you notice here, I didn't really change the function at all. I added 9 to each side. That doesn't change the function. The function still is this here, because if I subtract 9, I go right back to this function. So this is the whole completing the square part. You take the middle term, you divide it by 2, and you square it, and it gives you this number in here that now will allow you to complete the square with this middle portion here. So really what I want to do is then, if I can put this in parentheses and focus just on this, I can write this in terms of a square. So x squared plus 6x plus 9 is really going to be two binomials being multiplied. So that's x in this term, x in this term. So I'm going to write f of x plus 9 here. Well, what do I have to do? I need the two terms on the outside to add to be 6, but then multiply to be 9. Well, that's obviously going to be plus 3, and then I can write that as x plus 3 squared minus 14. And the last thing I need to do is I need to subtract 9 on each side, and that would be f of x equals x plus 3 squared minus 14 minus 9, which is f of x equals x plus 3 squared minus 23. Vertex form. So this is vertex form. And you can see to complete the square, just to recap, complete the square, you take the middle term divided by 2 and square it, and that's going to give you a number that you can add to both sides. Add it to both sides, and then now you can actually make and factor this down into a square to make it look like vertex form. This equation is the exact same as this equation. Okay, remember, because we added 9 to both sides, we didn't change anything. Now I can actually figure out what the vertex is. Well, the way I figure out the vertex, to figure out the vertex, I look and I say, all right, this is plus 3. Well, in the original equation, it's minus h. So that's got to be a negative 3 for x. Minus h, it's got to be negative 3 for x. So really, when I plugged in a negative 3 here, that's why it became positive, because minus negative 3 would give you the plus 3. The other way to think about it is, what number would zero this out? Well, that number would be negative 3. Negative 3 plus 3 would be 0, so that's the number, or the x value for the vertex. And then the y value is going to be this one out here, which is minus 23. And that's how you convert from standard to vertex form.